In medical imaging, consistent image representations are of vital importance. Physicians make life-critical decisions every day, so they want to be sure that their clinical images look accurate and consistent on every workstation in their department and for the full lifetime of their displays. To help achieve this long-lasting confidence, Barco has engineered two different stabilization technologies. One is called backlight output stabilization, or simply BLOS. The second is named I-Guard. Let's take a closer look at both these technologies. But before we do, let's see how an LCD monitor actually works. Liquid crystal displays get their light from a tray of lamps mounted at the back of the LCD. These lamps form a very powerful light source, but due to aging and changing environmental conditions, their luminance is not stable over time. Also, when you switch the display on, it may take up to 30 minutes before its backlights reach a stable luminance output. BLOS and I-Guard are two Barco technologies that have been specifically engineered to overcome this inherent instability of backlight lamps. So, how do they do this? In essence, BLOS and I-Guard are light measurement technologies. Both systems use high-precision light sensors to constantly measure the light output of the backlights. Based on these findings, the luminance of the backlights is readjusted in real time. The difference between both systems lies in the position of the sensors. While BLOS measures via a sensor at the back of the display, I-Guard gets its data from the front. BLOS uses a built-in sensor that is mounted at the back of the display, close to the light source. The BLOS sensor continuously monitors the light output in search of fluctuations or downfall. If the luminance no longer meets a predefined value, more power is applied to the backlights to readjust the white point of the display. I-Guard monitors the display's performance just the way a radiologist does, from the front of the display. Because of its front-mounted position, I-Guard does not only stabilize the luminance of the backlights, it also deals with additional causes of instability. To understand this, let's follow a light beam on its path from the light source up to the moment it hits the actual screen surface. On its way, the light passes a number of consecutive optical layers. The behavior of each of these layers shifts over time as a result of aging and changing environmental conditions. First, there's the diffuser. As time goes by, the color and transparency of a diffuser tend to change. The front-mounted I-Guard sensor will notice this diffuser browning, as it's called, and will perfectly compensate for it. And there's more. The transparency of the diffuser also wavers with changing temperature values. Here again, I-Guard will notice this cause of instability and level it out. Thirdly, there's the LCD panel itself. Its transparency is also dependent upon changes in temperature. Again, I-Guard will measure these instabilities and compensate for them. On a color display, the color I-Guard sensor measures the individual red, green and blue values, as well as the white light generated by the display. This results in very consistent color representations over the full lifetime of the display. In short, the sensitive I-Guard optical eye sees exactly what a radiologist sees. As such, it is the ultimate guarantee for long-term diagnostic confidence. I-Guard is an integral part of every Coronis display system. Positioned in the corner of the actual viewing area, it guards the image quality unnoticeably, without disturbing the diagnostic reading sessions. In spite of its peripheral location, the I-Guard's measurements are extremely precise and fully representative for the entire screen surface. Before leaving the Barco factory, every I-Guard sensor is meticulously matched to the screen's center luminance, so that even when it's reading in the corner, It is virtually monitoring the center of the screen where the actual diagnoses take place.